Welcome to this explainer. We're feeding billions of people on a planet that is absolutely packed with unforgiving environments. Today, we're going to unpack the sheer scale, the wild ingenuity, and some seriously startling contrasts in modern agriculture, all using data straight from our source material. So if you've ever wondered exactly how we manage to sustain life in places that literally seem designed to prevent it, you're in the exact right place. Let's get right into it. Here is our roadmap for today's explainer. First up, conquering the harshest continents. Second, precision in the desert. Third, the blue agricultural revolution. Fourth, the global mechanical army. And finally, the enduring human touch. Okay, so how do you farm a continent with no water, basically no nutrients, and only 2% of the population actually working the land? It's the ultimate paradox of Australia. They've somehow overcome some of the oldest, most nutrient-poor soils on the planet, not to mention a severe lack of fresh water, to rival giants like the US and Brazil in the global food supply game. How exactly do they pull this off? Section 1. Conquering the harshest continents. This is all about the massive industrial-scale engineering required to conquer that unforgiving Australian landscape. To really wrap your head around this, you have to anchor yourself to one staggering number: 1 billion. Australian farmers harness over 1 billion acres of agricultural land. That is so massive, it literally transforms farming into something resembling an endless, roofless factory. And when you're dealing with that kind of acreage, timing is everything. They enforce strict 24-hour golden windows to manage the scale. The timeline is super precise. Mechanical harvest, transport from the field, and then straight into processing and packaging. Take the almond industry, for example. Specialized machines sweep up and filter the harvest right there in the field, moving 100,000 tons of almonds to processing within just 24 hours. Why the rush? To lock in that natural crunchiness. And we see the exact same urgency with cotton. They wrap these massive 2-ton round modules in plastic, and they have to be transported away immediately before any residual moisture can degrade those pure white fibers. It's all about removing the element of chance. We're talking fleets of GPS-guided wheat harvesters acting as real-time analytical centers to keep the grain moving 24/7. They let the wheat dry naturally to below 12% moisture right in the field to completely eliminate industrial drying costs. And then you have these 175 horsepower machines harvesting 20 tons of wine grapes an hour in the pre-dawn cool. By picking them at night, they actually prevent premature fermentation in the intense heat. Honestly, it's an absolute masterclass in efficiency. Section 2. Precision in the desert. Because if Australia relies on massive scale, while Israel survives on meticulous control. So how do you survive in a true desert? Israel does it using reverse osmosis technology. They use incredible energy recovery systems to compress incoming seawater, which drops production costs to a record low. We're talking under $1 per cubic meter. This setup supplies a massive 80% of their domestic water straight from the Mediterranean Sea. But here's the catch. Desalinated water is just too expensive for wide-scale farming. So, to actually sustain agriculture, they activate urban wastewater. And they reuse an astonishing 90% of it. They push this contaminated water through massive aeration tanks and pressure filters, and then direct it to the desert. From there, it percolates down 100 meters, literally using the earth itself as a giant biological filter. That regenerated water safely sustains over 60% of agriculture in the Negev desert. It's mind-blowing. Think about the stark contrast here between backbreaking traditional flooding and modern drip irrigation. Historically, farming in this region meant hauling heavy buckets under a scorching sun, and most of that water would just evaporate away before it did any good. Today, it's a completely different story. Drip irrigation delivers these precise microdoses directly to the root zone, exactly where it's needed. The soil surface stays completely undisturbed, and it nearly eliminates evaporation entirely. And the results? Pure desert miracles. Instead of fighting the 45 degrees Celsius heat, they actually use it to naturally trigger sugar accumulation in medjool dates, yielding an insane 120 kilograms per tree. When the desert soil is dead or totally unusable, they switch to suspended hydroponics, pulling up to 400 cherry tomatoes from just a single plant. They even enlist bumblebees in sealed greenhouses to boost fruit set rates by 20%. Oh, and while all this is happening, AI-driven apple-picking robots with vacuum grippers are working seamlessly through the night. It is a total reimagining of what a desert can actually produce. Section 3. The Blue Agricultural Revolution. We're leaving the desert behind now and wading right into the wild frontier of the open oceans.
In the punishing open sea, traditional square cages are basically a non-starter. They develop fatigue points and eventually just fail under the constant stress of the waves. But circular cages, they use this ingenious absorb-disperse balance mechanism. When a massive 3 to 4 meter wave hits, the force travels smoothly around the circular frame. This allows the whole structure to ride the wave rather than stubbornly fighting it. This kind of brilliant engineering is exactly what unlocks those deep, oxygen-rich waters for large-scale offshore farming.
Now, let's look closer to the shore. For Asian shrimp farming, delivering pure oxygen microbubbles has been an absolute game changer. Think about it. Traditional paddle reels only stirred the surface, but shrimp actually live at the bottom, which can get pretty toxic. By compressing pure oxygen into high-pressure microbubbles and driving them straight into those deprived bottom layers, it cleans up the habitat entirely. This strengthens the shrimp's immunity and boosts survival rates by an incredible 20%. But here's the really cool part. This blue revolution isn't just about food. Take Europe's mechanized offshore seaweed farms. These farms serve as massive carbon sinks. They grow entirely on natural ocean currents, zero fertilizers required, and they're actively capturing 10 to 30 tons of CO2 per hectare every single year. It's a model of agriculture that is literally healing the environment while it grows. How awesome is that? Section 4, the Global Mechanical Army. This is where agriculture gets completely standardized by the unstoppable rise of heavy robotics. And let me tell you, this global mechanical fleet takes some truly wild forms. Just imagine agile steel monkeys automatically scaling and perfectly pruning a 30-meter tree in just 3 minutes. Obviously, that's way faster and safer than the biological alternative. Meanwhile, you've got these mini tunnel machines that are literally unrolling and building continuous greenhouses by the hundreds of meters every single hour. From Realmeyer fertilizer sprayers gripping incredibly steep 40-degree mountain slopes to Israel's Edgard chili harvester, or massive V-shaped harvesters pulling 3 to 4 tons of delicate parsley root an hour, human limitations are just being completely engineered away. And on the most extreme end of brute force, we're seeing these massive V-shaped blade plows slicing a whopping 70 centimeters deep into rock-hard, suffocated soil. But instead of just tearing the land apart, they actually lift and awaken that dead earth from below. This preserves its natural structure while opening up pathways for roots and air to finally return. Section 5, the enduring human touch. Now, in a world full of supreme automation and these massive steel machines, we arrive at our final twist. Despite having fully automated options right at their fingertips, Spain consciously chooses the human hand to manually snip 70% of its lemons. Workers use specialized shears specifically to ensure they don't damage the glossy, oil-rich skins of the fruit. That meticulous manual labor is exactly what preserves the sun-soaked aroma and protects the essential oils that define their premium export quality. All told, they're hand-clipping over 1.2 million tons of perfect lemons a year. You see a really similar story in Castroville, California. Workers move carefully through the artichoke fields at sunrise. And they aren't using high-tech sensors out there, they are relying on generations of pure intuition. They have to cut the perfect 7 to 10 centimeter bud exactly 5 centimeters below the head. And they have to do it before the bud opens and loses its tenderness. It really is a craft of touch and timing because even a short delay means the artichoke completely loses its market worth. It perfectly echoes this quote, "In a world racing toward automation, the artichoke stands as a quiet rebellion, a reminder that not all beauty can be accelerated." Because ultimately, between the earth, the grower, and time itself, there's just this delicate harmony that no machine can truly imitate. So, I'm going to leave you with a thought to ponder. We've seen technology master 1 billion acres of harsh land, conquer the desert, and engineer survival out in the open ocean. But looking forward, as automation standardizes absolutely everything, will the ultimate luxury of the future simply be the human touch? Thanks so much for joining me for this explainer today, and definitely take a moment to consider what the future of our food truly means to you.